Hello, everyone. This is Mr. Bing. It is February 23rd, 2021. On February 23rd, 1971, I was born, which makes this my 50th birthday. Yes, everyone, it is my 50th birthday. So anyway, to celebrate my 50th birthday, I would like to go over one of the problems, one of the more difficult problems from Project Lead the Way, Principles of Engineering, assignment number 1.2.3, SIM. And so what we're going to do is take this circuit. They have some information about a bulb and step 8, which is above. I'll just, do it again, I guess. Bulbs 2 and 3 should be off. Okay. Close the switch and note what happens to the first light. Rearrange the image. So basically, before we do any of that, we need to make this circuit on the simulation, which is PhET, P-H-E-T, Physics and Engineering Technology, I think is what it stands for, from the University of Colorado. And so this was a circuit that I was working on before, so I'm gonna erase that, reset to nothing, and I have a battery here and a bulb here and then 2 bulbs there and a switch. So let me see, a battery here and a bulb here and 2 bulbs here and here. And then I have a switch, I guess, kind of there. Let me look at it again. All right. No, these are just measurement, multimeters or ammeters. Don't worry about putting that in the circuit. But I think I've got battery, bulb, switch, and then I need a bunch of wires connecting everything. And I try to make it as much like the schematic as possible, even though you can get away with not doing that. And so you'll see me sort of put my wires in a particular arrangement. So it looks like the schematic. And this light bulb, let's see here, that goes there. Light bulb here. I hope that I'm basing this on memory. I went to the Hamilton Family Diner in Allentown. The Ham Fam is what a lot of people call it. And there were like 6 people in our group, and the server did not write anything down. She just remembered everything we said, like 6 different people, with all the different orders, and coffee or soda and chocolate milk and hash browns and lobster bisque soup. But anyway, I'm trying to remember what was, just like she did, I'm trying to remember what was in the schematic. I know there was a battery and a light bulb and then 2 light bulbs. And then there was a switch. Let me see, I'm almost there, I think. Trying to make all the wires look like they're supposed to look. Ham Fam, please check it out. The Ham Fam, Hamilton Family Diner. Okay, very, very close to J. Bernie Crum football stadium, Allen High School. I almost said the University of Allen. Okay, anyway, so there's the circuit. I hope that I got it right. Battery, light bulb, and a switch. And I don't know if it specifies, but the battery traditionally, or the default for the battery is usually 9 volts, okay? And then they say here 10 ohms, and 75 ohms, if you're counting this as 1, 2, and 3. So this is defaults to 10. This one is also 10, and I don't remember. I guess I'm not as good as the server. Oh, there we go, 75, okay, 75 ohms here, 75 ohms. There we go. So I think I've got the circuit pretty much set up the way that I want it to go. And notice that the switch is open. Switch is like a little gate. You close it and you get, these light bulbs lit up. You open it and these light bulbs get nothing. And so only that light bulb is lit up. So here it says there's the schematic, the voltage across the battery. Well, right now it's open, right? Circuit, close. Oh, close the switch. All right, close it. And it says, look what happens. Well, this light bulb is still lit and it's pretty bright, but these 2 got a little bit lit too. Tiny bit lit, little dim light. This one a little bit more. Let's call that a dim, then a medium, and a bright. So that's what happened when we close the switch. And then they're asking for the voltage across the battery. So you use a voltmeter because it's voltage across the battery. And what across means is on each side of the battery. I put a little sensor or a little probe or whatever that thing is called, and I connect it from in front of the battery and then behind the battery, and I get a voltage of 9. So what I would do is write in my notebook, the voltage across the battery is 9. The voltage across bulb number 1, well, this one is bulb number 1, so I put the probe in front of and behind. That's what across means. Looks like it's also 9. Voltage across bulb number 1 is 9 volts. Bulb number 2, which I think is this one, so I go in front of and behind that bulb, I get 1.06. Interesting. I had a 9-volt battery, 9 volts going through this light bulb, and it looks like I got 1.0 volts going through that light bulb number 2. And then it says the voltage across light bulb number 3. Well, let me see, I got that. Put the probe in front and behind. And this one I got 7.94. The first one I got 1.06, and the second one I got 7.94. So I hope that sort of is triggering something in your brain about those two numbers. And then the current at bulb 1, well, current, this is a voltmeter or a multimeter, they call it in the real world. But I need an ammeter or a current meter, amps, current at bulb 1. So I take this current meter, stick it right on bulb, there we go, 0.9 amps for the current at bulb 1. The current at bulb 2 and 3, okay, that's I'm getting a little nervous about that. Do I put it at 2 or do I put it at 3? Or do they both have the same current because they're along the same path? And that is correct. They both have the same current because they are along the same path. Think about current like water flowing through pipes. This is electricity flowing through wires. The current is going to be same all the way through this single line of wires and bulbs. Okay, then it says the total current. Okay. Well, I've got the current here, which is 0.11, and I've got the current here, which is 0.90. Do you add those together? Do you add them together? I think you do. I think you do. And that makes sense to me because you got 0.9 and you got 0.11. What do you know? You add them together and it gets 1.01. I hope this is making some sense. And I guess that's all. It says calculate the total resistance for the combination circuit, show your work and include units. Perhaps I'll do another video of the actual handwritten work on paper. But for right now, I think that pretty much covers at least assignment activity 1.2.3 sim number 16, which is the hardest circuit in my opinion in the simulator, the FET simulator. And oh, don't look at that. Okay, yeah, look at that. There's my engineering notebook. I have not. This goes all the way to step 15. So what you see here is step 16. So I need to take screenshots of that and write anything down on the notebook that I need. Okay, that's going to conclude this video. And so this is one of my very rare, decent videos. I've done some really bad videos, right, guys? But this video is pretty good. So bye for now.